Hello and welcome. It's time to review some of the problems and solutions on the theory of sets. If A is a set of elements -1 and 3 and B is a set of elements x such that x squared plus 2x minus 3 equals 0, we are required to find the relationship between A and B. Set B is the set of roots of the polynomial x squared plus 2x minus 3 equals 0. After factorization, the polynomial becomes x minus 1 times x plus 3 equals 0. Therefore, x is equal to 1 and minus 3. Therefore, the set B is the set of elements 1 and minus 3. Thus, we can clearly see that sets A and B are not equal. Neither there any element between them is common. Therefore, A is not equal to B, and also A intersection B is an empty set. Also note that two sets whose intersection is an empty set are called disjoint sets. In this problem, we are required to write all the subsets of the sets of 5 factors of 42. The factors of 42 are 2, 3 and 7. Therefore, the set of factors of 42 is the set of elements 2, 3 and 7, and its subsets are an empty set, a set of element 2, a set of element 3, a set of element 7, a set of elements 2 and 3, the set of elements 2 and 7, the set of elements 3 and 7, and the set of elements 2, 3 and 7. We also know that the set of all the subsets of a set is called the power set of that set. The number of elements in a power set of any set is equal to the power the number of elements in that set. In this case, the number of elements in the set A is 3. Therefore, the number of elements in the power set of A is equal to 2 to the power 3 equals 8. In this problem, if we have a set A having elements 1, 4 and 9 and set B having elements 2, 4, 6 and 8, we are required to show that A union B complement is equal to A complement intersection B complement. For this problem, we can assume that the universal set is a set of natural numbers from 1 to 10. Union B is having all the elements in set A and set B. Therefore, A union B is equal to 1, 2, 4, 6, 8 and 9. The complement of A union B will be having elements that are there in the universal set but are not there in A union B. Therefore, A union B complement is 3, 5, 7 and 10. Similarly, A complement is 2, 3, 5, 6, 7, 8 and 10, and B complement is 1, 3, 5, 7, 9 and 10. The intersection of these complements is all the elements that are common in these sets. Therefore, A complement intersection B complement is 3, 5, 7 and 10. And we can see that complement of A union B is equal to the intersection of A complement B complement. Thus, A union B complement is equal to A complement intersection B complement. We have a committee. 50 people in the committee speak French, 20 people speak Spanish, and 10 speak both Spanish and French. We are required to find how many speak at least one of these two languages. The committee by the universal set U, and let us denote the people speaking French by the set F and the people speaking Spanish by the set S. Thus, number of people speaking French, that is N of F, is 50, and number of people speaking Spanish, that is N of S, is 20, and the number of people speaking both the language, that is n of f intersection s is 10. We are required to find n of f union s, that is we are required to find at how many people speak at least one of these two languages. From the set theory, we know that number of F union S, number of elements in F union S is equal to number of elements in F plus number of elements in S minus number of elements in F intersection S. Substituting the known values, we find that n of F union S is equal to 50 plus 20 minus 10, which is equal to 60. Thus, 60 people speak at least one of these two languages. In this problem, we are required to show that power set of A intersection power set of B is equal to power set of A intersection B. To show that power set of A intersection power set of B is equal to power set of A intersection B, it is required to be shown that power set of A intersection power set of B is a subset of power set of A intersection B, and it is also required to be shown that power set of A intersection B is a subset of power set of A intersection power set of B. So the proof of this problem goes in two parts. In the first part of the proof, we will show that power set of A intersection power set of B is a subset of power set of A intersection B. We will start by assuming an element X in power set of A intersection power set of B. Since this element is in power set of A intersection power set of B, this element is in power set of A as well as power set of B. This means that this element is a subset of A as well as subset of B. This means that this element is a subset of A intersection B, and this means that this element is in power set of A intersection B. Thus, power set of A intersection power set of B is a subset of power set of A intersection B. In the second part of the proof, we will show that power set of A intersection B is a subset of power set of A intersection power set of B. Again, we will start by assuming an element X in the power set of A intersection B. Since this element is in power set of A intersection B, this means that this element is a subset of A intersection B. This means this element is a subset of A as well as a subset of B. And this means that this element X is in power set of A as well as this element is in power set of B. And this means that this element is in power set of A intersection power set of B. Thus, power set of A intersection B is a subset of power set of A intersection power set of B. Combining these two proofs, and from the definition of equivalence of sets, we get that power set of A intersection power set of B is equal to power set of A intersection B. Required to show that A union B minus A is equal to A intersection B. We will show this using Venn diagrams. Suppose we represent the set A using blue color and set B using pink color. In this figure, the pink region represents B minus A and the blue region represents A. The union of A and B minus A will contain all the elements within this blue region and pink region. This region is also A union B. Therefore, union B minus A is equal to A union B. Given that A intersection X is equal to B intersection X is equal to 5, which is an empty set, and it is also given that A union X is equal to B union X. We are required to find a relationship between A and B. We will first take the intersection of this equation A union X equal to B union X with A and apply distributive law. So after taking intersection of this equation with A, we get A intersection A union X equals A intersection B union X. Now when we intersect A union X with A, we get the set A itself, and applying distributive law on A intersection B union X, we get A equals A intersection B union A intersection X. Now since A intersection X is an empty set, we get A equals A intersection B union phi. This means A equals A intersection B, and this means A is a subset of B. Now again taking the intersection of this equation A union X equal to B union X, but now this time with B, and applying distributive law, we get B intersection A union X equals B intersection B union X. Now intersection of B union X with B gives the set B itself, and applying distributive law on B intersection A union X, we get B equals B intersection A union B intersection X. We are given that B intersection X is an empty set, therefore B equals B intersection A union phi. This means that B is equal to B intersection A, and this means B is a subset of A. Now since A is a subset of B and B is a subset of A, this means that A equals B.